Now in this 8th class of polarization, we have to study what is retardation plate. A doubly refracting face cut such that its refracting face is parallel to the optic axis, and the thickness of the plate is such that it produces certain path difference or phase difference between ordinary ray and extraordinary ray is called as retardation plate. The retardation plate are of two types. One is quarter wave plate, another one is half wave plate. How much phase difference it produces or how much path difference it produces depends on the thickness. And what is quarter wave plate? If the doubly refracting phase cuts such that its thickness produces the path difference between ordinary ray extraordinary ray is equal to lambda by 4. If it produces this path difference, or if it is a path difference, phase difference is pi by 2. It is called as quarter wave plate. So consider it is unpolarized light falling on the doubly refracting plate. So when it falls, you know that the beam is divided into two. One is ordinary ray, another one is extraordinary ray. So if thickness of the plate is chosen such that it produces the path difference is lambda by 4. If NO is the refractive index of ordinary ray, then NE stands for the refractive index of extraordinary ray, and T is the thickness of the plate. Then for negative crystal, if you take the negative crystal, we know that this NO is greater than NE. For negative crystal, NO is greater than NE. Then this optical path difference can be written as, since NO is greater than NE, it is NO minus NE into T. But for quarter wave plate, this path difference should be lambda by 4. So this is your lambda by 4 is equal to, it is NO minus NE into T. Therefore, your T is lambda upon 4 NO minus NE. Call this equation as 1. This is for negative crystal. If the crystal is positive, we know that NO is less than NE. If NO is less than NE, then this equation becomes T is equal to, what is this, lambda divided by 4, it is NE minus NO. Call this equation as 2. This is for quarter wave plate. And what about half wave plate? Second one is half wavelet. What is half? So the thickness of the plate is such that it produces the path difference of lambda by 2. Here your path difference should be lambda by 2. If the path difference is lambda by 2 and for negative crystal and positive crystal for half waveplate it becomes lambda by 2. Thickness T is equal to lambda upon 2 into NO minus NE. Then for positive crystal, this thickness T is equal to lambda upon 2 Ne minus NO. So call this equation as 3 and another equation as 4. So in this manner, we have to compute the thickness of the retardation plate. If the thickness produces lambda by 4 path difference, it is called as quarter wave plate. If it produces path difference of lambda by 2, it is called as half wave plate. Then we should know what is circularly and elliptically polarized light. What is circularly polarized light and what is elliptically polarized light? The superposition of two plane polarized light such that their plane of vibrations are perpendicular. They produces circularly polarized light and elliptically polarized light. Superposition of two rectangular plane polarized light produces circularly polarized light and elliptically polarized light. How? So consider this is a vector, means one plane polarized light, and this is another plane polarized light. They are perpendicular. This is plane polarized light and this is also plane polarized light of equal magnitude. Equal magnitude means their length is same. If they superposed, their resultant is in this direction. The resultant of these two. Then if this reverses the direction, if this reverses the direction here, now what is the resultant of this? Now the resultant of this is in this direction. Assume that this vector reverses the direction here. Then what is the resultant of these two? It is in this direction. And assume again if this reverses the direction, it becomes this side. And the resultant of these two is in this. If you join the tip of these resultant vectors and the tip of the resultant vectors describes the circle. Such light is called as circularly plane polarized light. And what is elliptically plane polarized light? If the two plane polarized light of different magnitudes superpose, different magnitudes, means length is different. Assume that this is one plane polarized light and this is another plane polarized light. So magnitude of this vector is maximum. Now the resultant of these two becomes in this direction. Not exactly at the center. In the same manner, if this vector becomes this side, at that time you are going to get the resultant here. And if this reverses the direction, it becomes here. And again another one is here. And now if you join the tips of this, it is not a circle, it is an ellipse. Therefore, the resultant is called as elliptically plane polarized light. Now next we have to study production and detection of circularly polarized light. So first we have to produce and we have to detect it. When a plane polarized light with the plane of vibration making 45 degree with the optic axis of this quarter wave plate. This is the quarter wave plate. So when a plane polarized light with its plane of vibration is falling on this such that it makes an angle 45 degree, the light which is coming out from this quarter wave plate is circularly polarized light. Then when this circularly polarized light is observed through the Nicol prism. Nicol prism is a device which can be produced and detect the plane polarized light. Is directly observed through the Nicol prism by rotating this Nicol prism. No change in the intensity of the light is observed. That means directly we are focusing on this circularly polarized light using this Nicol prism here. So if you go on rotating the Nicol prism, no change in the intensity of the light is observed. That light is circularly polarized light. But if this circularly polarized light is allowed to fall on another quarter wave plate, this is another quarter wave plate, then if you go on observing the intensity of the light which is emerging from another quarter wave plate, intensity is maximum at one position and minimum 0 at another position. That means it regains the original plane polarized light. Now, the light which is coming out from this quarter wave plate is plane polarized light. Now here it is circularly polarized light. If the circularly polarized light is allowed to fall on another quarter wave plate, circularly polarized light is converted to once again the plane polarized light with the vibration making 45 degree with this optic axis. So this is production and detection of the circularly polarized light. Then in the same manner we have to study about elliptically polarized light. See, when a plane polarized light is allowed to fall on the quarter wave plate such that the plane of vibration makes an angle other than 0, 45 and 90 degree. That means it should not make an angle 0 degree. It should not make an angle 45 degree. It should not make an angle 90 degree. It may make between 0 and 45, or it may make 45 to 90. So if such a plane polarized light is incident on a quarter wave plate, the light which is coming out from this quarter wave plate is elliptically polarized. It is elliptically polarized now. If this elliptically polarized light is observed through the Nicol prism by rotating about its axis, the intensity of the light goes on changing with a minimum which is not equal to 0. With a minimum intensity, again it is maximum intensity. Again, if this elliptically polarized light is allowed to pass through another quarter wave plate, this elliptically polarized light is passed through another quarter wave plate and observed through the Nicol prism, again this original plane polarized light is observed, which is not at an angle of 0 degree, 45 degree and 90 degree. Now this is elliptically polarized light is produced here and which is detected after passing through the another quarter wave plate. Now you should know what is optical rotation. If the plane polarized light is allowed to pass through certain materials or certain substances like that sugar solution or quartz, this is a plane polarized light is allowed to pass through the material. Assume that this is the sugar solution, and after passing through this sugar solution, this plane of polarization rotates and this phenomena is called as a rotatory polarization or optical rotation. It is sometimes it is also called as optical activity. If the plane polarized light is allowed to pass through the certain substances like that of sugar or quartz or fructose, then this was the vibration in this direction. After passing through the plane of polarization is rotates through certain angle. This is called as rotatory polarization or optical activity. Then the substance which rotates the plane of vibration or plane of polarization is called as optically active substance. Water does not rotate the plane of polarization. It is optically inactive. The substances which rotates the plane of polarization, that substance is called as optically active substance. That is called as optically active substance. Then there are two types of optically active substance. One is called as a dextro-rotatory substance. Another one is called as levorotatory substance. What is a dextro-rotatory substance and what is levorotatory substance? If the substance rotates the plane of polarization in the clockwise direction, in this direction, on the right side, right-handed rotation. Such a substance is called as dextro-rotatory substance. So if a substance rotates the plane of polarization towards the left in this direction, after passing through the solution or substance, if that substance rotates the plane of polarization towards the left, that is called as a levorotatory substance. Example of dextrorotatory sugar solution and levorotatory is fructose. Fructose rotates towards the left or in the anti-clockwise direction. Some substance rotates towards the right, some substance rotates the plane of polarization towards the left. Those substances which rotates towards the right, they are called as a dextrorotatory substance, and those substances which rotates towards the left, they are called as levorotatory substance. Now lastly in this chapter, you have to study Fresnel's theory of rotatory polarization. We know that the plane polarized light on entering certain substance rotates the plane of polarization. This is called as optical activity or rotatory polarization. Fresnel has explained why this rotatory polarization takes place. So Fresnel's theory of rotatory polarization is based on a principle that a linear vibration is equivalent to two opposite circular vibrations of same frequency. That means, according to Fresnel, the plane polarized light on entering the substance is broken up into two circularly polarized waves rotating in opposite directions. In optically inactive substance, the two waves, one is counterclockwise wave and another one is clockwise wave, travels with the same speed. Therefore, there is no rotation in the plane of vibration. Then in dextrorotatory substance, the clockwise wave rotates faster than the counterclockwise wave. There exists a phase difference. In levorotatory substance, it is different. Counterclockwise wave rotates faster than the clockwise wave. Hence, there exists a phase difference. Then, on emerging this substance, the two waves recombine to form a single plane polarized light rotated through certain angle, whose angle of rotation depends on the phase difference between the clockwise wave and anti-clockwise wave. I think this completes your entire topic, our entire syllabus assigned to me.